continue the fun with applications of right triangles. Before we do the application, I want to solve a triangle. And when it says solve a triangle, that means find all three sides and also find all three angles. So for this one, let's say that the triangle was a right triangle, and this is 17 degrees. This side is 10. This side is W, and this side is V. So solve for V, solve for W, and also find this missing angle. Well, that missing angle is actually the easiest part. I'm just going to do that right now. So if this is theta, then all three angles have to add up to 180. Since this is already 90, that means that these two have to add up to 90. So we would have theta plus 17 is equal to 90. And then subtract 17 from both sides. And that will be 73. Okay, so that part is done. Now what about the sides? So using the 17 degrees, that means that this is the opposite and this is the adjacent. Opposite over adjacent, that's the job of tangent. So tangent of 17 equals W over 10. And then multiply both sides by 10. And use a calculator. So make sure it's in degrees. And then it's 10 tangent of 17 degrees. So W is equal to 3.057. All right, now what about V? So I'm going to use the 10 and the V, so this would be the adjacent and hypotenuse. Adjacent over hypotenuse, that's cosine. So cosine of 17 degrees equals the adjacent is 10, the hypotenuse is V. I could then multiply both sides by V, and then it would just equal 10. And for the last step, to solve for V, divide both sides by cosine of 17. So 10 divided by cosine of 17. So that means that V is equal to a 10.457. And then this is done. We solved the triangle. Now, before we go on to more of the applications, I want to solve a more complicated triangle. So this one isn't solve the whole thing, but so this is example number 2. And suppose the picture looks like this. It's one big right triangle. Now pick a point somewhere on the bottom of it and divide the triangle like this. And now let's say this is 50 degrees. This is 28 degrees. This is 12. This is X. And this is Y. So there are applications that are like this. So a person wants to know how tall this building is. They stand here and they measure the angle of elevation to be 50 degrees. Then they move 12 feet farther away and they remeasure the angle, and now it's 28 degrees. Find X and find Y. So to begin with, I'm just going to look at that little right triangle right there. Using the 50 degrees, it's going to be tangent of 50 equals the opposite over the adjacent. So that's one equation. Tangent of 50 degrees equals opposite over adjacent. Now if you have two variables, you need two equations. So for the other equation, I'll use tangent of 28. This will be the opposite, and the adjacent is going to be this bottom part, which is x plus 12. So the other equation looks like tangent of 28 degrees equals the opposite over the adjacent. Now for each one of these, I want to solve for y. So for this one, multiply both sides by x. And for this one, multiply both sides by x plus 12. Okay, now because they're both equal to y, that means they have to equal each other. So x times tangent of 50 degrees has to equal x plus 12 times tangent of 28 degrees. Now what I need to do is distribute this tangent of 28 degrees on the right side. So the left side can stay the same for right now. Did I just say the right side? The left side can stay the same for right now. The right side will be x times tangent of 28 degrees plus 12 times tangent of 28 degrees. Okay, good. We're getting close to being done. This has an x and this has an x. So what I should do is put everything that has x on one side. So I need to subtract this term. So the left side will have x tangent of 50 degrees and then minus x tangent of 28 degrees. And the right side just has 12 tangent of 28 degrees. Now since each one of these has an x, you could factor out x. And that would leave tangent of 50 degrees minus tangent of 28 degrees. And the last thing to do to solve for x is you leave the x here and you divide both sides by this. So x will equal, take the 12 tangent of 28 degrees and divide by tangent of 50 minus tangent of 28. So there's a 12 tangent of 28, and it gets divided by, and I need to put this in parentheses so the calculator understands all of that's in the denominator. So tangent of 50 paren minus tangent of 28 two parentheses. So x is equal to 9.667. Okay, so this x is done. We still need to solve for y. So just use this equation right here to solve for y. So y is equal to, so for x, plug in what we just got, 9.66 right here for this x. So it'll be 9.667 times tangent of 50 degrees. And with that, we're going to be done. So it's 9.667. I could say take that last answer times tangent of 50 degrees, and 11.52 is the value for y. Okay, then for application. This is example number 3. So this man stands 200 feet from the base of a building. And then finds the angle of elevation to the top of the building. And the angle of elevation is 31 degrees. So how tall is the building? So this is going to be the building, and I need to know its height h. This is assuming that the building is standing upright, that it's not about to fall over. And this person is standing 200 feet away. An angle of elevation means looking from the ground up to the top of the building. So this is the angle of elevation, 31 degrees. Now solve for h. Well, since this is opposite and this is adjacent, that is the job of tangent. So tangent of 31 degrees equals opposite over adjacent. Now to solve for h, just multiply both sides by 200. So 200 times tangent of 31. And the building is 120.172 feet tall. So that's about a 12-story building. Each story is about 10 feet. So if you divide by 10, that's about a 12-story building. Then for example number 4. So sometimes when you're driving down a highway, especially if you're in hills or mountains, it might say, caution, there's a steep grade ahead. And if it's a steep grade down, that could be dangerous if your brakes are not in good condition. Suppose that this road has a 6% grade. And we're going to look at it as if you're going up the road. So it's an angle of elevation since we're going up. So find the angle of elevation. So you're driving along this flat road, and then somewhere it starts to go up the mountain. Then what is this angle right here? Well, usually it tells us what a side of the triangle is, but this one does not. It gives a percent instead. So first of all, I could rewrite the symbol as the word percent. And then if you take that apart, it is saying per 100. Or in other words, 6% is 6 per 100. So really, it's giving you the rise over the run. So it's telling you the slope, just like in algebra, rise over run. So in other words, it's going to go up by 6 feet vertically if you go over by 100 feet horizontally. So this is really telling you the slope is 6 over 100. Okay, now to find out theta. Well, that's opposite and this is adjacent, so it's going to be tangent of theta equals 6 over 100. And there's only one last thing to do to solve for theta. Take tangent inverse of both sides. Okay, tangent inverse of 6 over 100, and it equals, oh, that's a pretty cool number, 3434. 3.434 degrees. So about 3.5 degrees, it doesn't sound like that much, but when you've got a vehicle that is several thousands of pounds going up or down the road, then it could be a little bit tricky. So usually grades aren't more than like, I think it's around 8%. Because if it's going to be more than 8%, it's too steep. So then they'll make it go around the mountain and go like this so that it doesn't go above about 8%. All right, so we're done with this section. The next section is going to be similar, but we're going to be doing bearing.